In this video, we're going to examine threads. Java threads allow class objects, processes, and methods to be run simultaneously alongside of other objects and processes and share processor and memory resources. In this way, Java programs can multitask and do several things at once. The processor will rotate its attention between threads based on the priority value given to each thread when started, and the processor affinity, number of cores, and physical CPUs present within the system's hardware. When multiple threads share a single CPU resource, rapidly alternating between CPU cycles, it is known as time slicing. The amount of time allocated to each thread is referred to as a quantum. Multithreading, as its name implies, uses multiple threads simultaneously. A thread object is an instance of the thread class. You may create your own classes to run as threads and derive them from the thread class using extends. Every thread object or class that extends thread must implement the run method. A swing JFrame or JApplet is itself a threaded process. There are several methods that pertain to thread class objects. Start starts a thread. Stop stops a thread. IsAlive determines whether a thread is running or not. Set priority sets the priority on a thread. Priority is based on a value from 1 to 10. 10 is the highest, 1 is the lowest, and 5 is the default. There are also 3 built-in constants which may be used: min priority, norm priority, and max priority. There is get priority, which gets the priority of a thread, and then of course there's sleep, which pauses the thread and counts in milliseconds. Sleep is probably one of the most useful methods or functions with thread objects. Using the thread sleep method. Let's take a look at some thread methods. Primarily the sleep method in this example. So we're going to draw an animated stick figure, and we're simply going to use draw line and draw oval. Now, when we get down here, we're going to call the sleep function, and this will kind of provide some of the animation. We're going to pause for about 1/4 of a second, or 250 milliseconds, and we simply call thread.sleep. Whenever we do this, we have to enclose this inside of try blocks, and we have to catch an interrupted exception when we call the sleep method, in this case on the main thread, the thread that this applet will be running in. So let's see what that looks like when we run it, and we'll resize the applet a little bit. You can see. So about 1/4 of a second, and then we're erasing and redrawing the arms and legs. Now, what would happen if we didn't sleep? In other words, what if we commented these 3 lines out where we're pausing for 1/4 of a second? If we didn't call the thread sleep method, then watch what happens when we run this. Alright. And generally, that's not a very smooth animation there, so that's just one example of using the sleep method. In this next JApplet, we're going to create 2 bouncing balls that move in opposite directions. And once again, we're going to call the thread.sleep method to sort of smooth out the animation effect. So in our paint method, as our JApplet is painted or refreshed, we're going to call ball1 and ball2. And if you look at the functions, we're going to simply use draw oval with the color. And then we're doing just a little bit of math here in comparison, so that in this case ball1 and ball2 will move in opposite directions. Notice that in both functions, we're calling thread.sleep and sleeping for 25 milliseconds. Okay? So let's see how that looks if we create this JApplet here. We'll build it. And notice there's our 2 balls. Here's a third example where we implement a scrolling banner. And we're just going to pass in 300 milliseconds here. We're calling thread.sleep. And that'll be how much we pause before we move the banner across the screen. And here's what that looks like. You can see the string. And if we wanted to increase the speed of the banner, let's say we set this to 50 instead of 300. And let's rerun it. Notice our banner scrolls a whole lot faster. So you can see probably one of the more useful methods from the whole thread class object is the sleep method here. You can do a lot with it. Here's a fourth example, and we just have a JApplet and some JButtons, and we're implementing action listener. And In this example, let me go down here. We can create different smiley faces just using some of our graphics functions, but we can also call animate. And in the animate method, notice that we're just sleeping or pausing for a second, sleeping or pausing for a second, sleeping or pausing for a second, sleeping or pausing for a second. And in this case, we're just alternating back and forth between smile and frown. And here's the smiley face, and here's the frowny face. So let's run it and see how it looks. Nothing yet. Here's the frowny face, here's the smiley face, and then if we animate it, alternating back and forth, smiley face, frowny face, smiley face, frowny face. Here's the arcade game Poly Battlefield, and notice that it implements runnable. Well, when I implement runnable, I have to include a run method that's abstract or required when I implement the runnable interface. And in my run method, notice what's happening. I have a thread object which gets my current thread, in this case the thread that our applet is running inside of. And I'm going to go call the sleep method here and just wait or pause 20 milliseconds. And again, here's what that looks like. Now also, I have attack player missiles and attack player mines, which the enemy objects will employ against the player. And notice that the behavior is a little bit different. Here I'm going to sleep or pause in a separate thread for 1 second or 1000 milliseconds. And on the other hand, if the player chooses mines in the configuration JFrame, it's only going to sleep for 300 milliseconds. And that's if enemy attack style, in this case, well, that's a completely different thread or threaded process. And again, let's go look at the start method here. You can see how that looks. In this case, main game loop is a new thread and enemy attack window is a new thread. And they have priority set here, priorities of 1. This is a boolean, depending on whether it's true or false. We'll also go ahead and set priority on the enemy attack window. So back to the run method. Let's see how that looks. And in this example, we'll set it to missiles and then mines. Alright, so let's look at enemy fire. Enemy fire is turned on. Let's choose mines. And now I'm going to choose multi-threading and setting thread priority. Now we've examined the sleep method. In this next example, we're going to look at the priorities of threads and setting the priority and how it affects the performance when you're multi-threading. So we're going to create a class called monster, which extends thread. So every monster will therefore be a child object of its parent object thread. Here's some globals. Every monster can have a name. And then in this case, in addition to the name, the run method is going to be rage. So we'll build our monster, and when we call the start method on the thread, the run function is going to then turn around and call rage, and our monster goes into a rage. We're going to loop here. In this case, number of loops, and right now number of loops is 20. So 20 times, and our monster will go into a rage. Whatever their name is, they're going to attack the city and then we'll display counter. And then first, second, and third, depending on what the value of counter is. And then finally, we'll increment counter and we'll keep iterating through our loop. And we have a couple of accessor methods here to return our private data. So that is our threaded class. We're going to build threaded monsters. Now let's create a JApplet class so that we can then turn around and build monster objects and see how priority works with our threads. And that's what the second class is here. Here's our JApplet class. We extend JApplet. We're implementing action listener. In this case, we have a J button. We're going to click on it. And flow layout, and here's our constructor, not doing much there. But here's our init function. We're adding our components. Everything's all set. And in the action perform method here, we're simply going to call the function rampage1 or rampage2, depending on whether or not we click button 1 or button 2. Well, let's see what happens. In rampage1, we're going to get graphics and assign it to a graphics object, set the font and color. we're going to draw a string beginning the rampage, and then we're going to instantiate 3 threaded monster objects right here. Godzilla, Mothra, and Snuff, passing in their names to the constructor. When we do this, we're going to set the priority of 1 on Godzilla, priority of 5, which is the default on Mothra, and the priority of 10, or the highest, on Mr. Snuffleupagus. Once we set their priorities, we're going to start Godzilla first, Mothra second, and Snuffleupagus third. Next function, Rampage 2, we're doing something similar, but now we're going to use our symbolic constants, min priority, norm priority, and max priority. Just doing the same thing. So let's run it and see how that works. We'll go run monster mash here. Alright, here's our class. Let me expand this a little bit. Alright. Flow layout is, let me resize that. There we go, get flow layout. Alright, so we're going to do Rampage 1, and this was setting the priorities of 1, 5, and 10. Okay. And beginning the Rampage 1, and notice when we do this, Godzilla attacks the city for the first time. And then it's Godzilla, 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 and Godzilla just keeps right on going all the way to the 11th time. Well, who had the highest priority? If we scroll down here, let me collapse this window over here with my method. Who had the highest priority? In this case, Godzilla had the lowest priority. However, he started first. But because Mothra and Snuff have higher priorities, they're going to cut in on Godzilla before he finishes. And that's what happens here. Godzilla gets to the 11th time, and then Mr. Snuffy here, Snuffleupagus, he cuts in on him. Why? Well, what's his priority? He has higher priority. So even though he started last, he's going to cut in long before Godzilla finishes because his priority is higher. And once Mr. Snuffy cuts in here, first, second, third, let's just scroll all the way down, and Mr. Snuffy goes all the way to 7. And finally, Mothra comes in. Even though he started before Snuff, although he did start after Godzilla, his priority was only the default of 5. Okay, so then Mothra comes in. And then Snuffy gets 8, 9. And Snuffy goes all the way here, all the way down to 20. Okay, and then when he's done, now Godzilla gets some of his attacks in. He gets to finish up his attacks. So the highest priority thread, even though it started last, finished first. Godzilla has the lowest priority, but he started before Mothra. So he's already at 18 now. Even though Mothra started after Godzilla, he has a higher priority, a default priority. So let's see what happens with Mothra. Mothra keeps going. He gets all these attacks here. He keeps going. He keeps going. He keeps going. He gets to the 20th time. And then finally, even though Godzilla started first, he's going to finish last because he had the lowest priority. And that's what happens when we're running 3 thread objects simultaneously side by side with different priorities. You can see how the priorities affect the thread objects when we call the method setPriority. Now remember, Rampage 2 was doing something similar, but instead of using numerical values, we're using the symbolic constants min priority, norm priority, and max, which is still basically the values of 1 and 5 and 10. Same thing we had up here. So let's run it. We'll do Rampage 2, beginning the Rampage 2. And again, let's look up here. Here's Godzilla, and then Snuffy cuts in because he's got higher priority. And Snuffy gets to finish his attacks. And then even though Mothra was started before Snuffy, Snuffy had higher priority. Now Mothra goes, and Godzilla was started before Mothra, but he has lower priority. So again, just notice the behavior of these threads as all 3 of them are running side by side together. See how priority affects how much CPU time each thread gets. Mothra gets all the way to 18 before Godzilla gets a chance to even go a 4th time. And this is something known as thread starvation. When a thread is of a very low priority and it doesn't get enough time or CPU cycles to run because of other threads, then we call that thread starvation. So in this case, finally Godzilla gets another crack. He goes a 4th time. Then Mothra goes the 19th time. Remember, Mothra was in the middle there. And then Godzilla gets his 5th time. Mothra gets his 20th time. And even though he started first, Godzilla finally gets a crack at it at the very end, and he finishes last. So again, the same results. And you can see how setting the priority on a thread affects how much CPU time it gets when it's running alongside of other threads in a multi-threaded application. Finally, we get to the swing worker thread. Multi-threading and using the standard sleep method with a graphical user interface can be tricky. For the duration of this method, the JFrame or JApplet GUI can become unresponsive where it shares processes with the same thread being put into the sleep state. To alleviate this issue, the beloved selfless open source benefactors who bequeathed to us Java, Sun Microsystems, now assimilated by the Oracle Collective, gave unto us the swing worker thread. This was a bit of code you could download from their site that provided a true multi-threading technique for use with JFrame and JApplet graphical user interfaces. Just include it as a class in your package and instantiate it. I'm using several different kinds of thread objects here, but also primarily a swing worker thread object. So notice I have in this case an abstract class swing worker, and I just downloaded this from Sun's website. And it's very useful when you're multi-threading things and you want to create several threaded processes that can run simultaneously. So all this code is pretty much directly from Sun Microsystems, I guess now called Oracle, but this is a swing worker thread. Just Google swing worker thread, or you can copy it off the website or just copy it from the video here. Okay, so notice that it basically just launches a threaded process. Whatever we pass to it, it kind of takes over, and whatever code we're going to put inside of its methods, in this case, will run as a separate threaded process. So that's our swing worker object. Now over here in game functions for Pirate Arena, I'm using several different threaded methods. First, I have a wait function, and it just uses the plain old vanilla normal thread.sleep method, and it will sleep or pause for however many seconds I pass in. But if I were to simply call this in a combat loop, then what it would do, unfortunately, is lock up my interface, and the player wouldn't be able to do things like switch weapons or interact with the interface while they were stuck in a combat loop. So instead of calling it on a normal thread, instead I want to call the sleep method and actually therefore wait on a swing worker thread instead, what we got from Sun Microsystems. So let's go down and look at create battlefield. And all create battlefield is going to do is simply instantiate or launch a new poly battlefield object, and that's just a JFrame that'll pop up, and there'll be like a little bit of arcade action going on there where you get like a defensive move, and if you're successful you do 100 points of damage, and if not you don't. And we're going to pass in the player and CPU objects so we can get attributes on those objects on that poly battlefield. Okay, and now when we do this, we're going to instantiate or build a new swing worker object. Okay, this needs to happen as a multi-threaded process here, because lots of other things are going to be happening at the exact same time. In other words, I don't want to, I don't want things to lock up, or I don't want the player to not be able to interact with the interface. As a matter of fact, there'll be like 2 JFrames displaying, or actually no, excuse me, 3 JFrames displaying, a main window, the opponent window, the arcade action window. There'll be a JApplet that launches things, a splash screen. There'll be a combat loop, plus I want the player to be able to switch back and forth between controls. So all of that would not work right if it were not for this wonderful swing worker thread object. So I build a new swing worker, and when I construct it here, I'm going to, basically in an infinite loop, simply call update on bfield, the battlefield object. And when I'm finished, I'm going to basically close the window and dispose of it. And then I start the thread there. Okay, well, when that happens, here is my combat function. And again, this is another swing worker. So we have one swing worker that will end up launching another swing worker. But in combat here, what happens? Well, I had some buttons that were disabled on my interface, so I'm going to enable them. I'm going to stop the theme music playing, which is just an audio clip. I'm going to build a new opponent frame here, and I'm going to call create battlefield. Okay, and that takes care of all of that. And we just covered create battlefield. Then I'm going to come down here, and I'm going to call display stats on my player objects. And then I'm going to launch battle sequence. Now notice all of this, I'll highlight the curly brace here so you can see. All of this takes place in the construct method of our swing worker object. We're building this on the fly, and if you look at the opening curly brace here and the closing curly brace way down here, all of that is part of a swing worker class object, alright, threaded object. So you can see how that works. Let me scroll up a little bit more. So you can see all of that, right? So in other words, This swing worker will turn around and launch other processes or other threads that are themselves, child objects of a swing worker class object. And finally, when we're all done after battle sequence, we're going to determine who the winner was in our combat sequence. Okay? And I need to be, again, very careful that, especially this method, battle sequence, is called within the context of that swing worker thread and not outside by itself. Otherwise, my whole interface would lock up and the player wouldn't be able to interact and click buttons and change things on the interface with the game. So I do it that way, and then if you look at battle sequence, let me go down here and find it in the navigator pane. Drop down to battle sequence here. Battle sequence is just sort of like Mortal Kombat, and I'm calling wait, and then I'm giving, a little bit of randomness there depending on who gets the first attack, and then either the player attacks the opponent or the opponent attacks the player, and then there's a counter attack, and we pause and so forth. But all of that takes place as a separate threaded process in a swing worker thread. So let's launch the game and see how the process works in a swing worker thread. And here are all my interfaces. I have a JApplet and several different JFrames here. So we'll launch the JApplet splash page. And when we do, we're going to click on the launch button, which will then spawn a JFrame, which is sort of the main game window. And I'll just minimize that and minimize that so you can see we'll leave this right where it is. And let's click on start. Alright, and I'm going to go ahead and turn the music off here again so you guys can see. Well, actually, no, let me turn it on. I'll just turn the volume down when I compose the video because I want you to be able to hear the audio clips and how they work with the swing worker threads. Alright, so I'm going to come down here and I'm just going to put a tilde in right here. There's a little cheat. It gives me all the items. I'm going to walk over here using key listener and the arrow keys. Or I could use my nav buttons, either way. And when I do this, I have to select the right key. So I select key 1. That'll let me in. Now, I'm going to go north again into Arena 1. I'm in the Arena 1 corridor, and when I do, it'll spawn that battlefield, alright, that poly battlefield. And 2 JFrames will pop up. Poly battlefield over here, and my opponent over here. And it's going to launch everything, including battle sequence, in a swing worker thread. So even though I have all this stuff going on, it'll be multi-threaded. I'll still be able to interact with my interface, and I'll still be able to click back and forth between JFrames. Okay, so here we go. And I'm going to try... Alright, so over here in this JFrame, I got my defense. Alright, here's my opponent's frame over here. And notice here's the battle sequence, the combat loop that's going here. So I'm going to... Notice I can attack, and I can defend. I can choose weapons. I'm going to choose the Glock in this example. Alright, so I did some damage there. Did some damage. Alright, doing 92 points of additional damage. And you can see the JFrame over here in this example being updated. Okay, so there's 10 more points of damage. And then firing the Glock. Then fire the Glock some. And you can see I finally wiped out my opponent. Alright, those JFrames are gone. Plays the fight song, or the end fight song, the victory song, and then starts the theme music back. And I can click on go to continue. And now I see a guy over here, he's, again, I can buy stuff from him if I want, so I go west. And then I can buy things. If I want, the buy frame pops up, and I can chat if I want.